NFT, so nutrient film technique, and they actually move automatically. So they start from one end of the building and they get harvested at the other end of the fish farm is underneath it. The CO2 that is generated from the fish comes up through the plants underneath the NFT.
Welcome to Visionary Aquaponics, a podcast dedicated to inspiring a global aquaponics movement for food freedom, water wisdom, and permaculture-inspired aquaponics. Keep listening for the best advice from the world's pioneers and visionaries in backyard and commercial aquaponics. And now, here's your host, Maribou Latour.
This is Paul Van Der Werf. Paul describes himself as an integrated farming engineer from Brisbane, Australia, and is an integrated aquaculture designer with a strong focus on sustainable food production systems with over 15 years experience in agriculture, horticulture, and aquaculture design, project development, delivery, and management. Your mission has been to inspire, engage, and encourage everyone with a strong interest in fresh, high-quality food to embrace their desire to learn and enrich lives, and also to develop large, integrated aquaculture farming operations through sustainable growing methods in areas with low to critical growing resources. Hi, Paul. Thank you for being on the show.
Hi.
Tell us about your relationship with aquaculture and aquaponics.
Oh, well, that's a bit of a long story. It goes back a long time ago. I started my work in research with freshwater crayfish. I still conduct that research now with what's called the Australian Crayfish Project. So that's all done for love. There's no money in that. But it's about conserving, being crayfish are being a keystone species, and they're very sensitive to environmental changes. So they can be a very good indicator to, things like the current, global warming and things like that, because a lot of the more critical species live up in high ranges where if there's a sudden temperature change or any change really, it does have an impact on their ability to survive because they can't move any further up. So once the temperatures rise on top of these mountains, then these species will die. So they're a good indicator to climate, and so that's where my original work started.
Oh, okay. And so how did you move from crayfish into, for example, aquaponics?
Well, we went from crayfish to aquaculture because that was part of it anyway. I worked with large groups of commercial crayfish farmers here in Australia, and we were exporting live crayfish over to the UK, Spain, and various other countries, US as well. And so from there, we went into purging facilities. I built purging facilities to move the crayfish across. And then I did a lot of what we call bag carrying, if you like, my apprenticeship with a lot of leaders in aquaculture here in Australia. So I did a lot of work with them on design and learning how to do things, and that I spent nearly 10 years doing that. And then eventually my colleagues and my peers suggested that I go out on my own. And so I did, and I think it was about 6 or 7 years ago we started Earthen Group with the intention of still maintaining those relationships with my peers. So if we have projects that are outside my scope, certainly my scope of knowledge, we would bring those people in on those projects to assist in completing the projects and delivering the scope. So Earthen Group is a group, but it's a very loose group in terms of it's more a collaborative group. So, if they have projects that require my certain expertise, then I go and work with them. And if I have ones that require them, then they come and work for me. And from there, that led into, I've got a lot of, say, collaborators in hydroponics. I work very closely with the Protected Cropping Association here in Australia, and also I'm the president of the New South Wales Aquaculture Association. And so the two associations have been working for quite a number of years now to try to marry those synergies between the two culture techniques, between the fish and the plant side of things, which lends itself to a lot of science involved rather than just sort of experimental stuff. So that's where they called on me for my expertise in the integration with the fish farming side of things, and then I learned from them about the plant culture side of things, and that's where we came into aquaponics.
Great. Would you like to describe some of the integrated farming systems that you currently operate?
I don't operate any myself. I'm a designer, so but I do design and build them. There's quite a few. There's a large one in Sydney that I was part of the design team. There was something like 17 different engineers to build that. There's Cogeneration. It's a large 2-story, 9-metre tall greenhouse, or I should say out of glass, which has the fish farm underneath the plant culture system. The plant culture system is what's called a moving gully system, which is an NFT, so nutrient film technique, and they actually move automatically. So they start from one end of the building and they get harvested at the other end of the building. The fish farm is underneath it from a space-saving point of view. And also the CO2 that is generated from the fish comes up through the plants underneath the NFT. So that one's nearly in expansion mode. They've got one acre, so they're 4,000 square metres under production, and a 25-tonne fish farm underneath it, currently growing barramundi. They work exclusively with retail chains here in Australia, and they sell all their products through them. Unfortunately, they don't associate their product with aquaponics, though. They go with the whole locally grown, it's naturally grown, no pesticides, no all these sorts of things, herbicides and things like that. But they don't use the phrase aquaponics. I'm not entirely sure why. I do have some ideas why that might be. Another system in UAE, most people would probably know about that one. That's another acre under plant growth with a 40-tonne fish farm, separate facility that grows tilapia. It was built nearly 2 years ago now, and they're in full production. They've been in full production for some time. I stayed in the UAE for 15 months to build that facility, and then I stayed for 12 months to train the staff and get the facility up and running. And they're sort of the two biggest ones that I've done. I've done a lot of smaller integrated gardens, for aged care that have won a few awards and things like that, but they're not overly notable.
Are both of those large farms that you helped engineer, are they closed loop in that they recirculate, or are they decoupled? How does that work?
Well, they're closed loop. Well, as much as you can possibly close a loop.
Right.
Because you still have, obviously, your inputs. You've got energy inputs. You've got, you've got feed inputs. You've got labour inputs. So, there's a whole bunch of other energy inputs into the farm that in both of the farms. The culture systems, though, are separated. So the plant systems are using, obviously, the nutrient-rich water after biologically inoculating that water, and that's delivered to the plants. And it's circulated on the plants, and then the fish system is circulated on itself. So it's fully recirculating. It's 100% use of water. Nothing gets discharged. Well, they do discharge one in Sydney discharges to a retention pond, and they've come across a few difficulties from the food safety laws here in Australia where that discharged water cannot be brought back into the facility unless it's been treated with some sort of chlorine product, which sort of goes against their particular ethos in terms of not using any, nasty chemicals in their facility. So that's caused a bit of a problem for them to have that zero discharge. So the UAE is a little less concerned about that. That particular system doesn't discharge any water anywhere, being that it is in the desert. Any water that we may remove from the system, should we want to adjust things, that goes through their cooling system so that no water is wasted on the site. So they're as closed loop as they can be now, with having that, making your own feed is quite expensive and difficult to access things like organic feed, especially in Australia and in UAE. Mm-hmm. So they're as closed as they can be. Both facilities have looked into renewable energy sources. Obviously, UAE is in a prime position to use things like solar, but I would be more inclined for them to use solar heat with steam turbines as opposed to just solar. That way, you've got capacity for storing that heat and using electricity through the night. So they've both looked at it, but in terms of capital, they're both still at pilot stages, really. They are commercial pilots. But there's still not what we would call a commercial facility ready to go. So when they get their studies done and their understandings of their production capacities, and they see some positive cash flow, I expect then further investment will be made into alternative energy sources and other things that will help close that loop.
So have both of those farms, they sound very large, have they both been profitable already and had a return on their investments, or how long have they been going for, and how profitable are they at the moment?
So to my understanding, the one in Sydney was cash flow positive about 6 months ago. They've been running for about 3 years. It's a substantial investment from private enterprise. There was some government granting, which is a normal thing in farming here in Australia. You'll get a rebate depending on how much you spend. It's not necessarily grant funding, but it is a rebate on your investment. So it was a very, very large investment. It's very high tech, but they are selling all of their produce. They are profitable, but they're still probably another 12 months away from seeing any real impact, or I should say any real returns on that investment. The UAE is still struggling with markets. They're certainly producing mountains. The prices are very sustainable, but they're they had a buying contract from one of the retailers over there, but there was some exclusivity issues in that contract, which they're still working through. So I believe the retailer wanted exclusive supply to their supermarket chain and not to supply to anyone else. And that is really not a good agreement in business where you've got one customer and they then dictate to you what prices can be later on down the road. It might look attractive now where you're, to give you an example on a dollar arrangement, it's around about, say, 11 dirham per kilo to produce, and, they're paying 35 dirham to buy it. So, there's a 300% markup on sales margin. So it's very profitable, but they're still tying those things down. Their investment was certainly a lot less than the one in Sydney, so I expect to see them having those returns a lot sooner, as soon as they finalise the legalities of their dealing in these markets is very complex. It's very competitive and very complex. The smaller operations might work in a boutique market. That is very fragile and very high demand, if you like. They require a lot. They require a lot of service. The bigger guys just require the consistency in product. They require the consistency of supply, and that's it. So the markets are very, very different.
Mm-hmm. And so with either of these farms, emphasis on produce or the fish, or both?
Both are profitable businesses in their own right. So, and that's how they're designed. I'm not sure of the financial structure of the one in Sydney. I'm not privy to that information. But the one in UAE, the budgets for the business are set up very separately. So we take a percentage of the capital on each of the items, whatever it may be, because there is some shared resources in the facility. So we break up the capital. So in terms of depreciation against your cash flow, we break that up individually so that we can see exactly what our cost of goods sold are on each item, as opposed to saying, well, we're growing some plants and look, we can make profit from the plants and that pays for the fish. It doesn't work like that. It's not a very sustainable way to approach the business either.
Mm-hmm. And so are the crops and fish changing? Are adaptations being made due to the market or what's working in the system itself as it's been producing, or has it been pretty steady and regular?
The Sydney one's been steady and regular. They're doing barramundi, and that's part of their marketing plan. We had suggested as a startup with limited skills around aquaculture, they should possibly go for something as simple as jade perch. They're sort of like a tilapia. They handle a fair bit of rough handling. While people are learning, they're a bit more forgiving. The UAE one is quite difficult. It's very complex in terms of sourcing fish seed is quite difficult. It's got to travel long distances. We looked at getting barramundi and even jade perch from Australia, but they would have to be repacked in Singapore. Very expensive, and it wasn't sustainable. We managed to get locally tilapia. It's not a fish of choice over there because in the business terms, the tilapia lose money because they don't have that kind of value. I mean, they've got frozen fillets that have been imported for $1 a kilo and sold at about $1.70 a kilo. Local fresh ice stuff coming out of Egypt and Jordan and things like that. They're coming in extremely cheap. Around that $2.50 a kilo, something like that. So that's $2.50. You're looking at maybe $1.50 a pound. So it's not a sustainable product, no matter what density we put the fish system up to. It's not something that will stay. So later, as their skills come up, I'm dealing with people that have, they have trouble writing their own name in their own language. Some of the guys come directly out of the jungles of Pakistan, have never worked in a very structured business where everything needs to be done exactly how it should be done, and it's very repetitive. So it takes a long time for them to adjust to that. So they've had some time. They seem to be getting a handle on it now, and as their skills come up with the fish, they'll change the fish out to something that's a little bit more difficult to culture but has a lot more value in the marketplace.
Both of these systems are very high density in terms of fish. Is that correct?
Yes.
Okay. How many tons of fish did you say?
Well, one runs at 25 ton and the other one runs at 40 ton per year.
And how much produce then is produced for either one?
Around about the 200 ton mark per year.
Okay. So it's about a quarter of the pounds in fish, you're saying?
Yeah, it's going to depend. It's going to depend on what you're growing specifically. I mean, doing relationships between ratios on, fish volume versus plant volume won't work. It doesn't work. I mean, I could grow tomatoes and have a completely different yield. I can grow a very short-term crop that's a very high turnover and have a different yield again in the plant side of things. currently they're running the system at 20 tonne, and then they'll push that up as their market increases when they get access to the market penetration.
So you mentioned NFT. Were there also other types of systems in there, or was it all NFT? Or do you have deep water raft or media beds in those systems?
The one in Sydney, as I said, was a moving gully NFT, and the one in UAE is a deep water culture.
You have a great article about hybrid systems. I would love for you to talk about that and their relationship to commercial aquaponics.
Well, that's probably a fairly contentious item on everyone's minds currently, and it has been for some time. The use of media beds at a commercial level, I think that they have a place in low economic regions where there's no skills, it's all not very high tech, it's put out in the paddock, you could use sand or you could use media and gravel, where you don't have access to things like NFT, for example. Putting up a box with some bricks and putting a liner in it and filling it up with media is a pretty simple process. That may work where the money isn't at. That will work just fine. But it'll only work for a period of time before you need to do something with the media beds, and that requires a lot of labour. So if labour's cheap, you're happy to work on these media beds, then it'll work there. Take it into a Western culture, I think you're at a large facility, you're starting to, I think, ask for problems. You've got absolutely no control over the bacterial activity, and even though we have limited control anyway, but if you should have a bacterial outbreak, one of my clients had media beds and he had a Pythium issue in his system and it wiped him out. He couldn't treat it. He broke the system down, in other words, shut the system down and then treat it with chlorine, very heavy treatments of chlorine, and it still didn't kill it because of the organics that are built up in these systems. It just chews chlorine up. So you have to use a huge amount of treatment to get on top of it. When you come into food safety items, when you're talking about food safety, for example, UAE, I can treat water passing out into the raft system with ozone because we're using pure oxygen anyway. So when we're testing, it's part of our requirements for food safety. In our HACCP and whatnot, we have to test the water in all areas. We have to do benches and surface tests and things like that. If we find that there's a population growing of a food pathogen, then if we can notice that it's not enough for colonizing, but it's turned up and we identify an issue, we can treat it very, very quickly. Whereas in a media bed, you can't.
Right, because you have to pull all of the media out and you have to treat the media and clean it, and it's a lot of labor, I'm sure.
Look, I don't think there's a lot of risk in terms of food safety in these systems. Because really, how many gardeners in the world put, chicken poo and cow poo on their gardens and turn their soil up and then plant in it and then eat that produce? We're not dealing directly with animal waste. So E. coli is a very rare event in these aquaponic systems. We've never seen it, ever. Just the same, things like Pythium are a very, very big risk. It's one of the largest destructive, economic issue in hydroponics, and understanding that hydroponics are more of a sterile, they're not a biological system. So hydroponics doesn't rely on all the biologicals to work as they do in, say, an aquaponic system. So if you have an issue in hydroponics, it's very, very easy to treat it quickly, and quickly your business can quickly recover from it. Whereas in aquaponics, you start treating to kill something like Pythium, you will kill everything else. So
how do you deal with something like that? You said it's easier to treat it in a raft system, but how would you do that in this biological setting? Do you just take the water out? How do you do it?
Do you mean like in a raft system or an NFT system?
I mean in a raft system.
In a raft system, well, you can treat on the way past a bypass with ozone. Look, UV will work very well, understanding that all your surfaces within a raft and within your tanks and pipes, they will all still hold the good bacteria, but if you treat your water on a bypass out to the raft or back from the raft, whichever you like, UV will work if you've got very, very well filtered water. If you haven't got such very filtered water, then you would have to use ozone. Now, ozone will kill everything and anything in it that comes in contact with it, but you still maintain that biological presence in the surface of your rafts and all that sort of thing. So your rafts, and even between uses in rafts, you're cleaning the rafts and you're sterilizing the rafts in between crops. So whenever you're rotating your rafts out and you're putting in a new crop, you've sterilized those rafts for reuse. So the idea in the systems that I design is that biological activity is protected in a separate system.
Mm-hmm.
So if there's an issue out in the raft system, for example, it's something that we can treat quite quickly within a couple of hours and no hands-on and very limited cost. And our biologicals are separated from there so that we can reintroduce that biological diversity.
I know about using UV in water filtration, the plastic bottles, and you put them up on the roof, and as long as the water is filtered and doesn't have turbidity, you can kill the bacteria, and it's a great way to filter your water. I never heard of the ozone using that, and I definitely haven't heard of this in use with aquaponics. It's really interesting that you guys have developed systems in Australia to deal with large commercial aquaponic growing, and I just haven't heard of that here. So,
well, aquaculture have been using it for decades. So all we do really is we just take, as we say, what aquaponics is. We take the best from aquaculture, we take the best from horticulture or hydroponics, and we join the two together. And so that means across the board. So everything in an aquaculture system and everything that makes it a recirculating system is what is in an aquaculture system that is in what we would call, what we'd define as aquaponics. So, yeah, it's stock standard stuff. And really business in this sort of thing in growing environments and that is all about risk mitigation. And business is all about risk mitigation no matter what you do. You've got to try and avoid as many risks as you possibly can. If you identify that risk, then you need to look at how can we deal with it. So if you're looking at a business and you're growing produce, it doesn't matter. I mean, I farmed for years growing commercially bananas and pawpaws with rotational small crops in the ground. And mind you, we were throwing a lot of fertilizer on those things. But, we ran 40 acres of that 7 days a week. And the only thing that you don't have a lot of control over is nature. And if you're in a protected environment such as a greenhouse, then you want to have absolute control over everything. If you don't have that control over it, then you may as well grow out in the paddock and hope for the best.
Mm-hmm. So when you use ozone, you said you use it in a separate system and then you return it back to your fish tanks or to your rafts?
No. What we can do is treat a small bypass of water. So just straight from the pumps, say you're pumping back to your raft or your fish system, however you have it configured, you can run a bypass through your ozone treatment or add ozone to it on the way back to the fish or to the plants.
Okay. And that doesn't hurt the fish at all or the plants or the plant roots?
It certainly can. Yeah, it certainly can. I mean, if you overdose the system, you will kill your fish, you will kill your plants, it'll kill everything. So, you have to know what you're doing, but most of the ozone generators have a liters per minute injection rate that you can set, very specifically. And if you know what you need to set it at, then you'll have no problems.
So I'm assuming you guys don't use, anything like black soldier fly larvae or worms or duckweed or anything like that in your systems then, because you're worried about food safety. Is that, and the commercial viability of the production, is that right?
Well, we don't use them because, to feed, say, your fish, I think it's great at a small level and a backyard hobby level and that. And I think there's a lot of work being done on being able to feed fish, making fish feeds out of insects. I think there's a huge potential.
Yeah.
Huge potential. I mean, even, you look at Thailand, it's part of their cuisine, they've got big markets that are just chock-a-block full of insects for human consumption. It's not a food safety issue for us. It's more of, if we add another element such as, say, we needed to grow, say, black soldier fly larvae for production, for feeding the fish, then that's a whole other business again. Mm-hmm. That's another huge cost to the business.
Yeah.
Because one, you need the waste from somewhere. And yeah, you get a bit of waste out of your product, the leaves that are not sellable, unsellable products and things like that, to feed the black soldier fly. But at some point, you need to reintroduce nitrogen somewhere. So if you can't get, and there's options there to say go to restaurants and get that gear and then, put that into a system and feed your black soldier fly larvae. And then you do, from that point, you may have food safety concerns. It's not in every country. Laws are different in every country. And I think some of the laws are probably a bit silly where, if you use a worm or something like that. I know they tried feeding fish with worms and I saw one lot extracting, like just squeezing out the guts out of the worms to feed the fish. Hugely costly.
Oh my goodness. It sounds like a lot of work.
I think what we need to do is, we need to look at these things most certainly. We can't discard them, but we need to look at them from a commercial point of view. And, does it add value to the business, or is there a part of our business that we can add it to reduce some of the costs and maybe some of the environmental impacts? And that's something that you do over time. Like, I've often said that we're not sustainable. There's no such thing as sustainable. We're becoming sustainable. Sustainability is not something we are, it's something we're becoming. No matter where you start in these types of farming businesses, any kind of business really, being sustainable or environmentally sustainable, it's something that we're becoming because we are really an oil-based economy. And so everything we touch has got oil in it. So everything we use, the plastics, everything we use. Yeah. So it takes a long time to change from that. And have those sorts of alternate methods being accepted in the marketplace. So while that is great, I think it's something businesses today, especially in aquaponics, should be setting themselves up as businesses and meeting the market as the demand is, but certainly applying some of their returns to their research and development, which most good businesses will do, and have that as an aside where they are doing some research, they are applying some stuff, or they're using that research money, paying a university to do that research for them to help bring in better technologies and better methods. I don't think you should start a business today with, I'm going to feed my fish black soldier fly larvae and feed them on duckweed. I think you should start with what works, use proven principles, and then look at all those things that you think doesn't really work. It doesn't meet your ethos, it doesn't meet what you're trying to achieve, and then start working towards that. It's not something that you should walk out the door and say, I'm going to do all this and reinvent the wheel, because I'll guarantee you what they say is, the cutting edge is the bleeding edge. So if you really want to have an impact on agriculture around the world, I think it's important to embrace these things, but don't make them part of your core business. Make some money first. You've got to be financially sustainable.
Yes.
But do that, and then allow some of those funds. It's kind of like donating, It's like donating to hungry children and things like that. Allow some of those funds to go towards that kind of research.
Yeah. I agree. And actually, you probably know I'm a permaculturist. I've been studying permaculture, and so I like to think about different systems and stuff like that. But one of the principles is obtain a yield. You have to be able to obtain a yield in order to move a system forward, and you have to obtain a profit in order to, establish yourselves in this industry, and then start maybe finding other ways to alleviate costs and things like that.
How can you improve on it? It's like the two systems that I've talked about. They're looking at renewable energy. But, these are big energy chewers, that would require very large renewable energy infrastructure, which requires a huge amount of capital. So the first priority is to, create a product, grow a product, and sell a product. If you can make some profit from that and reinvest in turning your business even more sustainable and becoming more sustainable, then that's what you should be doing.
So you obviously live in a desert, and I was just wondering, if it's kind of like the desert that I live in, do you have extremes of cold and heat, or is it just hot all year round?
No. I think we've got something like 26 different climatic conditions here in Australia. Most of the coastal lines, from north to tropical down to temperate, and cold down into Tasmania. It's it's a lot of variety, but when you move off the coast and inland, then it's desert, and then you have those extremes of hot, cold, just like a desert does. But our coastal regions, where most of the population are, is very comfortable. It has all the trappings of if you're up tropical North Queensland, then you've got a tropical environment, something like the Caribbean. If you're down in temperate New South Wales, well, it's a bit wet and it's a bit cold at times. And if you're in Victoria, well, it's hot and cold and a mix of business, but generally pretty cold. Tasmania is just cold. So, but when you move inland in the mainland, when you move into it and move further west, say from the east coast, and even moving over into Western Australia, it's all desert. And there's not a lot of population out there.
Where you are, you said you're in Brisbane?
Yep.
And Brisbane is coastal or inland? Okay, coastal.
It's coastal, and it's a temperate climate, so, it gets warm in summer. Where I am, I might get a 40, 43 a few days of the year, and it gets cold. I'll get my, zeros and ones. That's about it in terms of Celsius. So, but it's, they're only short periods of time. They're not, so it's quite a comfortable area to grow and to live in.
I was just wondering because I wanted to know if passive solar design or passive cooling was something that you guys had considered in the design of the greenhouses in order to cut costs of heating and cooling, with active pumps and fans and ventilation and all that stuff. I was just wondering if that, if you guys do that at all.
No, not really. I mean, greenhouse side of things is not part of what we do. We contract people to build the greenhouses, yeah? So we say, look, this is where we're building it, this is the climate that we're dealing in, and they say this is what you need. We look at, when you talk about passive stuff, we look at cogeneration greenhouses, yeah? So that's sort of a little bit more effective than passive stuff. So, if you take Holland, I've been working now for about 6 years with a group out of Holland that are trying to build a 32-hectare facility here in Australia. His cogeneration greenhouses supply 23% of the Netherlands' power.
Wait, can you talk about cogenerational greenhouses? I've heard this term before, but I'm not familiar, and I don't know if a lot of my listeners would know. So this would be great to understand.
Well, it's probably a little bit beyond my understanding as well, but the basics of it is cogeneration means that, say, you're in a cold climate, and you might be using gas, for example, to heat a greenhouse, and they recapture that heat and use some of that gas to run turbines that produce energy.
Okay, so it's recycling some of the energies that are being created already and reusing it in the system itself.
That's a big permaculture greenhouse.
Yeah.
Renew and reuse and recycle. It's excellent technology. It's been around a long time, and if you're in a cold climate, they're the sort of greenhouses that we would apply, because you're talking about big facilities from my angle. I mean, when we're talking about an acre or more, a hectare under a greenhouse, or even 1632 hectares under a greenhouse, trying to get passive solar design into that is somewhat complex. Mm-hmm. And again, you want absolute control.
Mm-hmm. Yeah, that's a big question, is how to integrate, permaculture and passive solar and cooling design for these large commercial greenhouses, because ultimately they're going to be using the most amount of energy. But if they could raise the capital to build those greenhouses to begin with good design, then they wouldn't need to use as much energy in the long run.
Look, they've got wonderful materials now with greenhouses like glass houses, excellent diffusing glass. So, while they're expensive, they're extremely effective. So in terms of retaining heat and diffusing light properly, I mean, in big greenhouses, for example, if you can imagine 20 hectares, it's huge. Yeah, it's big. Mm-hmm. And having all this glass on the roof, and then there'll be a big patch in the middle of the greenhouse that isn't growing very well. And the reason for that is it's a big circle in the middle of the greenhouse, because the sun comes up and over, and kind of like a magnifying glass, it over radiates, if you like, that particular area of the crop every day. Mm. And so they've got some awesome automatic controls and fogging and things like that are fantastic at controlling whether it's too hot or too cold, or with limited, they don't use as much energy as they used to. So it's not just a polydome out in the paddock with fans and cooling pads. Some of this technology is amazing. Mm-hmm. But it comes at a big cost.
Some of the new technology, no kidding. I don't even know how much that stuff costs, but some of the new stuff I've heard recently is a type of solar panel that is transparent.
Yep.
That generates electricity, and
yep.
Yeah, and I'm not sure if it can shade or not. Anyway, I just interviewed somebody about it, so I don't know how much they cost and how viable they are for commercial growing, but
I don't think it's quite got to that stage yet, that technology. It's there, and it's out there, and I mean, they've had fogging glass for ages. It's a gas they put into a double-pane window that at a flick of a switch it fogs it. The solar panel gear that is transparent, I think it's still a little ways off before we start seeing that roll out in the commercial aspects, because it has to be used elsewhere before they'll put it into agriculture. And then obviously it has to be used a lot for the price to come down. So, it's kind of like solar power. I mean, in the last 10 years here in Australia, getting renewable solar panels on the roof of your house, for example, has come down, at least 100. It's well and truly not even half the cost now. It's about a third of the cost it was 10 years ago, because now a lot of people have it and there's a lot of investment in it, so it's cheaper. Mm-hmm.
So why don't you tell us about some of the smaller systems that you've built, the aquaponic systems, either at home or locally?
Well, one would be the Basin View village in the south coast of New South Wales in Australia. It's something in the order of, I don't know, it's 3,500 square feet. I don't know, it's a garden, yeah? Mm-hmm. So it's about 350, 370 square metres of growing space. We introduced what we call our earthen beds into that. That's where we're using soil in an aquaponic system. Mm. And it's a wonderful thing. It works really well. And look, this is in an aged care facility where the brief was to help with dementia patients and help them reconnect. And we've had there's studies being done on it by 2 universities currently with some excellent results where, you know, people that haven't spoken in years start speaking because they've spent some time around the garden. Now, it's not endemic to the design. There is some design facets to it. It's sort of like a maze to confuse them a little bit. It's supposed to be like that. You can't just have straight lines.
Right.
So the idea is they get lost in it. And so the results that they're having from the dementia studies where it's not about the food, and it's not about the design. I could have built a garden that's not aquaponics and it would have had the same effect. But the point is that that engagement, because we all understand food and I think a lot of people are losing that connection to food. And it's the thing that keeps us alive. It's what we exist on. And as they get older, older generations, they always gardened. A lot of people, like we're all trying to be like my grandparents. I mean, my grandparents had a garden. It wasn't a question. It was something they had to do and grow their own food and their own healthy food and all that sort of stuff. But then when they're into these aged care facilities, they're sort of removed from that. They lose all of that freedom and that connection. They just get fed their food and they go back to their rooms or whatever it might be. Their quality of life is diminished. So they invested substantially to build this garden. And so, the staff said what they wanted in it. There was a bunch of things in it that I wouldn't have put in it, but, I wanted their buy-in on it. So it was a big community project. And it's had awesome results. I mean, it won, what do they call it? It got highly commended for international salutogenic design. There you go. There's a new one. So that was up against, it's an International Academy Awards for Design. It was up against hospitals around the world and things like that. These are health facilities. And it's got it highly commended. So basically second place. And that's an awesome project. It still goes on. I'm going down to see it again in a couple of weeks. So it's still going, and there's still excellent studies being done on the health benefits to aged people.
So they are currently doing research studies on how it's impacting those people with dementia?
Yes. I mean, they've had some results. They've had some published papers on it. They had some excellent results. There's some long-term studies going on. Yeah, fantastic result. It's been written up in, health journals and things like that. It's got nothing to do with me. I don't do the studies, but they keep me abreast of it and let me know what's going on. And the universities are having a ball with it.
Yeah, that's amazing. Yeah, I look forward to actually reading some of those papers and putting them out there. So what kinds of things are growing in there? And you said it's mostly soil and fish, or is there any other medium or?
Yeah, there's 3 types of medium. I wanted to do it all in earthen beds, these soil operations. But they wanted floating raft and they wanted media beds. Obviously, they got online and searched for aquaponics and they ended up with wonderful things. And I said, fine, we can do that. It's quite a complex design. The fish water comes from the fish tanks. There's 6,000 litres of aquaculture tanks there, and the water comes out of there and goes to the floating rafts, and then it goes from there out to the media beds, and then it goes through the earthen beds, and then it goes back down through filtration and back up to the fish tanks again.
So you have a separate filtration tank or filtration area before it goes back into the fish tank?
I have separate biological filtration. Solids filtration I don't have, extra solids filtration, because it is very low density. The biological filtration is just, should we need to isolate any part? The garden can be isolated in 3 parts. So if we need to isolate the garden for whatever reason, it might be maintenance, it could be anything, the fish aren't compromised. And they have their biological filtration, and that's it. In terms of the filtration through the system, the primary filtration for solids is the rafts, because then all the solids settle out in that first. And then it skims off the top and into the media beds. They give it a little bit more of a polish, and then it goes into the earthen beds, the soil beds, and then it goes down to a sump, but it goes through the biological filtration anyway and gets pumped back up to the fish.
And what is your biological filtration made of?
Coldness. So it's an aquaculture biomedium.
I'm sorry, what was that?
Coldness. They call it K1.
K1?
Yep.
What is it exactly?
It's a polyethylene little thing like a cart, a cart wheel with spokes in it. It's a little plastic piece of media.
Oh, okay. I see. And so what does that do? It allows a place for bacteria to breed so that they can polish off the rest of the solids and eat it up and before it goes back to the fish?
Not so much solids, but it just helps with the nitrification.
Oh, okay.
The nitrification.
Okay.
Yeah.
Yeah, I think I've seen that. I haven't seen it here, but I think I've seen it somewhere online.
Oh, it'll be around.
So, did you say they're called K1?
Yes.
K1. Okay. I'll look into that. And what kinds of plants are growing in there? Do you have anything besides food?
Yeah, there's flowers. They love their flowers. They keep planting flowers in it. They love planting flowers. I don't know why. But they plant lots of flowers. They plant food. They've got everything. You name it, they're growing it. They did hit a bit of a brick wall. They had a change of legislation where the aged care facility itself cannot use the food from the garden. But the independent units, which is like houses where they just live independently, they can use the food from the garden, which is a shame. But at least, and everyone has a little segment and they all plant whatever they want. So it's not a commercial facility. It's more of an environmental, it's an environment, a happy environment. It's got waterfalls in it. It's got all sorts of.
So what is the impact of aquaponics in your area and in Australia? Do a lot of people know about it, or is it something that only gardeners know? What's it like?
Yeah, look, I don't think a lot of people know about it or even understand it. Word gets spread, but, people have an attempt at it in their backyard and find sometimes that it's too complex and they walk away from it. So that what you'd call like the turnover rate of people in aquaponics is extremely high. So they come in with all the bells and whistles and think it's wonderful and great, and then when they start doing it, quite a lot of them fall to the wayside and go back to their normal traditional gardens. Mm-hmm.
Because they try to do it themselves and then they don't have the proper information or training.
Well, there's not a lot of training you need. I mean, honestly, my 9-year-old could set up an aquaponic garden and wouldn't kill anything. It's a simple thing, but it's an extremely expensive way to grow food at home. Just, when you compare it to, say, a wicking bed or a soil garden or something like that, there's no energy requirement for the plants. The only benefit you've got is the fish. And generally, most people can't grow a large quantity of fish out to, harvestable, so they put it on the table. So that's where the skills involved. Growing in a media bed or a raft or whatever, there's no skill involved in that. Skill is in the fish. And what disheartens people is they get their fingerlings in, they're all excited, and they put them in, and then they kill them. And, that disheartens them. And that's hard for anyone. It's hard for me when I see dead fish.
And you think it's because they're more excited about the fish part of it, that they want to grow too many of them, or they just don't know how that works in the system, so it's not a balanced system, or what do you think it is?
Well, I don't know. Look, the fish is the novelty of aquaponics really at home, because anyone can grow food in a garden, or in a bucket. It doesn't require a lot of effort. So the fish is obviously the draw card. And a lot of people won't understand, what the limits are, and too many people go in too fast, too hard, Just get yourself a few fish, throw it in a tank, circulate it. A few fish will reduce the need for filtration and all these other things. It'll reduce the complexity of the system. Have a few fish, 10 fish in 1,000 litres of water. Go for it. Yeah? And then go through that and grow those. And as you get more confident with it in a year, remember this is long-term stuff. And in a year, you've got your first ones on the table. Fantastic. Then next time you put, fish in, you might say, well, I might get 15 fish this time. And just, it takes a while to get used to how to grow fish. Some people are good at it just by default. I don't know how, but some people are good at it. Other people are not. It's easier just to grow. You don't need that many fish to grow vegetables. You really don't.
No, you don't.
So,
that's where most people go wrong, is they want to put too many fish in because they're excited about the fish, but then you get too many nitrates and not enough plants, and then you kill your fish.
Well, it's not so much the nitrate. It's just that, it's just too many fish. Just back off on the fish. Your system then probably doesn't even need aeration. You don't need to be turning over water 100 mile an hour, so you don't need very big pumps. Everything can be very relaxed. If you want to get started, start there. Otherwise, you're going to set yourself up for disappointment. You know, I mean, my wife can grow fish in systems that I design while I'm not even here, and I'm often not here. Set up a system in the backyard and she can grow them and do nothing. There's no filter cleaning, no nothing. She doesn't do anything but top it up with water and feed the fish and not kill them. But that's in a system designed by me, and I've had a lot of experience designing them. So if you're starting out yourself and you've got a tank and you've got a bit of a grow bed or something, then just back off on the fish. You know, just back off. Put 10 fish in 1,000 litres of water and roll with that. Get a feel for it. And, you know, once you will get some skills up very quickly, because remember, you've got to harvest all these things. You've got to clean them and gut them. You don't even know whether you like that. You know, if you've never done fish before or never handled fish, you're not a fisherman or whatever it is. And when you've spent so much time with these fish, they tend to grow on you. And there's a bit of a pun in that, but I mean, you know, they grow on you, and you kind of get attached to them and start naming them and things like that. And then when it comes time to slaughter them, it's a whole other different thing. And these lively fish, they're not on the end of a hook. They're lively, and you've been looking after them, and you've got to kill them. Yeah. And that's not always easy. So, you know, practice with small amount of fish. Start there. Veggies will grow, no problem.
Yeah, I would say the number one thing that everybody I've interviewed has said about the mistakes that most people make is starting too big, too fast.
No, absolutely not. It's not about too big. Are you talking about from a commercial thing, or are you talking about backyard?
I think I'm talking about a commercial perspective, but what I'm saying is that everybody says start small.
Well, look, yeah, it's a good, but you need to identify what small is in your market. Yeah. So I mean, if you start small in your market and you can't keep up with the demand in your market, as in you start too small with the demand in your market, then you won't be able to supply. You'll lose clientele very quickly because they'll just slip over to the next guy that has it when you don't, and then you've got to do all the work to get them back, and that's an expensive experience. So starting small needs to be measured by what your market is and what access and what market penetration you think you can have. You're starting small. In your case, say, for example, say you and I were talking about a facility. We looked at the market and had a look at its feasibility, and then we said, well, the smallest you could start to make a dent in this market and be successful in this market is, it could be, in your case, it could be 10 hectares. That could be small. You with me?
Yeah. But do you think...
but you go to someone else's market and starting small might be one greenhouse.
But
you know, it might be 100 square meters.
But that is all based on experience. So if someone doesn't just start with a 10-hectare greenhouse if they have no experience, right? I mean, that's, I think, what a lot of businesses have made the mistake of doing is they go to one training and then they raise a ton of money, find the capital, and then create a huge business without the experience of, you know, learning the balance between the fish and the plants, and then it fails.
Look, I don't think that that's the biggest concern with aquaponics. I think the biggest concern is they start big and they don't have a market to sell into. You know, your capital's easy enough to recover. They're fairly low-cost operations if you don't get into the high-tech environment, controls and things like that. Look, and it's not about balancing between the fish and the plants. Not a lot can go wrong there. You know, I mean, ultimately, fish have never needed the plants to clean the water for them, and the plants have never needed the fish to give them nutrient. So, you know, the difficulties that you're gonna come across in the business is the business, not the systems, and certainly not the product. And that's, you know, if you start big, you might start too big for your market. You can't sell what you're producing. You know, I always tell people, look, if you're going to start, it's good to start small, but if you're going to start, identify what the end game is. What's your end market? How big do you want to be? Yeah. How big can your business, you know, how big can your market support? You know, what are your competitors doing? How big are they? Identifying what your niche is in the marketplace, you know, identifying what the problem is and solve it. So, and provide a solution for that. It might be specialized herbs. It might be whatever it might be. But you need to identify that first before you do anything. You know, I had a guy come to me last week. You know, he says, oh, I've got $50,000. I want to build an aquaponic system. And I said, well, where are you going to sell it? I don't know. And I said, well, why don't you spend, you know, $5,000 of that $50,000 to find out whether or not you can sell it. And, you know, identify your markets and then work out what your end game is. I mean, I think he's got 2 hectares of greenhouse ready to go, right? But he hasn't got anything in him. So, you know, find out how big you can grow, what you can support, and then introduce your systems, design your systems around that end game, but introduce your growing house systems. My suggestion would be to put the fish farm in the size that you need at the end game. Because remember, when you start a fish farm, there's bugger all nutrient. There's no nutrient.
Mm-hmm.
There's no nutrient density for your plants. So there's not much sense in having a 40-ton fish farm and then building 10 hectares of greenhouse and hoping you're going to have enough nutrient to support it. You won't. Because they're very fast turnover crops, chew through a lot of nitrogen, and you're not producing any. So you're going to end up supplementing, feeding some other forms of nitrogen to get your plants to grow. So you design your fish farm up to the size that you need. You can always increase and decrease your density in your fish farm, as long as you've designed for the end game.
Right.
Because the last thing you want to do is, and I'll get on to the other end of it, which is the plant side of it, the last thing you want to do is build a fish farm, put all this capital in and say, oh, I'm only going to run it at 20 kilo or 15 kilo per cubic metre. But then find, the market price, for your fish, you're talking about long-term investment here. 5 years down the track, 10 years down the track, the market value for your fish is going up and up and up, but your system can't cope with any increase. You have to replicate all of the infrastructure and do it again. So what you can do is start with the end game, with your fish, and lower your density, because that's a good place to start, because you haven't got this high risk involvement with high density. High density is very, very high risk. You've got 15 minutes to react. Something goes wrong, you've got 15 minutes to react to it. Otherwise, everything dies. So in the plant side of it, you can roll out your greenhouses. So in terms of your market penetration. So if you say, I'm going to have 10 greenhouses, this big, whatever the greenhouse sizes are, standard greenhouse, I'm going to end game is 10 greenhouses. I'm going to build a fish farm that will support those 10 greenhouses, right? I'm going to stock my fish because you're going to do stage production in your fish anyway. So you're going to have bugger all nutrient. Your first greenhouse, you set it up and away you go. Start selling that greenhouse and then roll out, okay, well, I've got good market penetration there. I've done some stuff into the restaurants or however you're selling it. Then I'll roll over into the next greenhouse and start again with the next lot, without interfering with any of your other production. Instead of putting in the 10 greenhouses and all that capital and trying to build it, you can start with your one greenhouse, like starting small, but have the end game in sight. Right. Have the end plan in sight.
Thank you for listening to the Visionary Aquaponics podcast. To learn more about aquaponics, please visit our website at www.visionaryaquaponics.com. There you'll find more strategies, tips, and tricks to get you started in your aquaponics journey.